So, hello, dear students. In last classes, we were solving the class 12th ISC Board 2026 paper, and we have solved paper up to section B. Today, we will solve section C, that is of 27 marks. Each question is of 3 mark, and there are total 9 questions in section C of total 27 marks. The first question is question number 9, as you can see on the screen. In this problem, you have to show the intensity of electric field at a point in end-on position, that is axial position of an electric dipole, and it is given by E is equal to 1 upon 4 pi epsilon naught into 2pr upon r square minus l square whole square, where the terms have their usual meaning. So student, this is a simple derivation, and we have solved this in class 2, and it is given in straightforward in your book also. So I'm not just solving this derivation, and if you have any problem in this derivation, then you can contact me, so I can make separate video for this derivation. So now next, come to question number 10. You can just see this question. First part, in the circuit shown in figure 4 below, there is a circuit. How much resistance should be connected to a 10 ohm resistor so that the points M and N, they are at the same potential? So students, in this problem, we have to show how much resistance should be connected to 10 ohm resistor so that the points M and N are at the same potential. So students, we will solve this problem. So students, to make M and N equipotential, let the unknown resistance, that is X ohm, unknown resistance X ohm, it should be connected with 10 ohm resistance. And here students, we have to also assume that the unknown resistance of 10 ohm and X ohm, it is R equivalent. Are equivalent ohm. Then students, as we all know that we, according to Wheatstone bridge, for balance condition, P upon Q is equal to R upon S. And here students, if you will see the circuit, here P is 3 ohm, Q is 6 ohm, R is 4 ohm, and S is modified 10 ohm. Now students, we'll proceed for the next step. So here students, P is 3 ohm. So here 3 upon 6, Q is 6 ohm, is equal to R is 4 ohm, and S is modified 10 ohm, that is R equivalent. R equivalent is, here we have, suppose, assume that the equivalent of 10 ohm and X ohm, and it is R equivalent ohm. So I'm just writing R equivalent in terms of S ohm. So here students, uh, if you will solve this problem, if you will simplify this, it will come out to be R equivalent. It is equal to 4 into 6 upon 3, and it will become 24 upon 3, and it will become 8 ohm. So here students, we have got our R equivalent as 8 ohm. So students, the equivalent of 10 ohm and X ohm, it is coming out to be 8 ohm students, and is this 8 ohm is less than, this 8 ohm is less than 10 ohm. Now students, to obtain the equivalent resistance of 10 ohm and X ohm, अब हमें यहाँ पे क्या करना है, 10 ओम एंड एक्स ओम का इक्विवेलेंट रेसिस्टेंस जो है, हमें क्या आना चाहिए? 8 ओम आना चाहिए। इज दिस क्लियर? तो स्टूडेंट्स हम यहां पे क्या करेंगे, हम यहाँ पे जो हमारा अननोन रेसिस्टेंस है एक्स ओम, हम उसको क्या करेंगे, हम उसको कनेक्ट करेंगे पैरेलल, इन पैरेलल विथ 10 ओम। और ये जो है टोटल हमारा क्या आना चाहिए? 8 ओम आना चाहिए। इज दिस क्लियर? सो स्टूडेंट्स विल प्रोसीड फॉर द नेक्स्ट स्टेप। So here your circuit will become, अगर इसको यहां पे क्या करेंगे हम, 10 ओम के अलोंग एक्स ओम का जो रेसिस्टेंस है उसे हम पैरेलल में कनेक्ट करेंगे। ये जो है एक्स ओम हो गया। So now friends we'll proceed for the next step. So here it will become 1 upon x plus 1 upon 10, it is equal to 1 upon 8. So here 1 upon x is equal to 1 upon 8 minus 1 upon 10. Now here 80, 8, 10 minus 8. So here it will come out to be 2 upon 80 and your x will come out to be 80 upon 2 and it is equal to 40 ohm. So स्टूडेंट्स हमारा x कितना आ रहा है? 40 ओम आ रहा है। तो स्टूडेंट्स हम 40 ओम का रेसिस्टेंस अगर कंबाइन करेंगे पैरेलल में 10 ओम से, तो हमारा इक्विवेलेंट कितना आएगा? 8 ओम आएगा। इज दिस क्लियर स्टूडेंट्स? सो स्टूडेंट्स 40 ohm resistance should be connected in parallel to 10 ohm resistance. So this was the solution of this problem. So students 8 ohm का resistance हमें कनेक्ट करना है 10 ohm से। Now we'll proceed for next problem. Next, here students, in second they are asking, uh, figure 5 shows a battery consisting of 3 cells. Their EMFs and internal resistance are also shown. In this problem you have to calculate EMF of the battery, and in second part you have to calculate internal resistance of the battery. So students, if you will carefully uh, see this circuit, then students, here student, 2 volt 1 ohm, it is connected in series with 4 volt 3 ohm. And students, this top branch is connected in parallel with lower branch. So students, first we will calculate net EMF of this top branch. So students, net EMF क्या होगा यहाँ पे? If you will see, net EMF ये सीरीज में है टॉप ब्रांच, तो ये नेट EMF will be 2 वोल्ट प्लस 4 वोल्ट, कितना हो जाएगा? 6 वोल्ट हो जाएगा। तो हियर स्टूडेंट्स net EMF it is equal to 2 volt plus 4 volt, and it will be equal to 6 volt. Now students, इंटरनल रेसिस्टेंस 1 ओम 3 ओम और ये भी सीरीज में है। तो स्टूडेंट्स हियर नेट रेसिस्टेंस कितना हो जाएगा? नेट रेसिस्टेंस it will be equal to R is equal to 1 ohm plus 3 ohm it is equal to 4 ohm. Now students, अब now top branch, that is 6 volt 4 ohm, it is in parallel with 6 volt 12 ohm, 6 volt 12 ohm. Now students, now we will calculate net EMF. हमें क्या कैलकुलेट करना था? नेट ईएमएफ कैलकुलेट करना था. तो स्टूडेंट्स, अब नेट ईएमएफ सेम होता है व्हेन कनेक्टेड इन पैरेलल, तो ये नेट ईएमएफ क्या हो जाएगा? 6 वोल्ट हो जाएगा. नाउ स्टूडेंट्स, वी हैव टू कैलकुलेट नेट इंटरनल रेसिस्टेंस. तो नेट ईएमएफ कितना आ रहा है? 6 वोल्ट आ रहा है. नाउ वी विल कैलकुलेट नेट ईएमएफ, नेट इंटरनल रेसिस्टेंस. तो ये क्या हो जाएगा? 1 अपॉन आर डैश, इट इज इक्वल टू 1 upon 4 plus 1 upon 12. So here it will be 12, 3 plus 1. So here it will become 4 upon 12. So R dash will become 12 upon 4 and it will become 3 ohm. So just net internal resistance is coming out to be 3 ohm. So this was the solution of this problem. EMF 6 volt and net internal resistance कितना आ रहा है? T. Now next. Now in question 11 students, we have to obtain an expression for magnetic field at the center of a circular coil having n turns of radius r when it is carrying a current I. So this derivation is very simple and it is B is equal to mu naught n I upon 2r. This you have to calculate. This you have to derive. ये एक्सप्रेशन आपको डिराइव करना था, तो सिंपल डेरिवेशन है. इट इज गिवन इन द बुक आल्सो. सो स्टूडेंट्स, you can just see, and if you have any problem, if you want the derivation of this, then you can contact me. I can make separate video for this derivation. Now student, next problem is 11 second A, two more moving coil galvanometer, G1 and G2, they are identical except for the following features. You can just see number of turns is given, area of the coil is given, and resistance of the coil is given. Now students, in the problem they are asking perform calculations to determine which galvanometer has greater current sensitivity. So students, we will proceed for the solution of this problem. So students, as we all know, current sensitivity, that is phi upon I, it is equal to NAB upon C. And students, if you will see, number of turns, area of the coil, and resistance of the coil are different for two galvanometers, G1 and G2. So here, students, and C, B and C, they are same for both galvanometers. They are same for both G1 and G2. So students, so here phi upon I, it is proportional to NA, number of turns and area of the coil. So students, for G1, first we will calculate for G1, phi upon I, it is proportional to, for G1, number of turns is 50 and area of the coil is 30 centimeter square. So here it will become 50 into 30, and students, your phi upon I, it will come out to be, if you will multiply 5 into through 15 into 100, 1500. So for G1, it is coming out to be 1500. Similarly, we will calculate phi upon I for G2. Phi upon I for G2. So if you will see, For G2, number of turns is 60 and area of the coil is 40. So here it will become 60 into 40. So students, phi upon I for G2, it will come out to be 2400. So students, phi upon I is greater for G2. So students, current sensitivity uh, will be greater for second galvanometer, that is G2, because phi upon I is greater for G2 as compared to G1. Now students, this was the solution of this problem. Now in second part, B part, they are asking, in a moving coil galvanometer, how is magnetic field made radial? So students, this is a very small derivation, and this derivation you have to just show current is directly proportional to deflection. So it is straightforward given in the book, and if you have any problem, then you can contact me. Now we'll proceed for the next problem. Now question number 12. Now in 12th problem, this problem is a little bit tricky one, but it's very simple. Figure 6 below shows a long straight conductor X carrying a current I1 at a point P. Is it at a perpendicular distance R1 from it? How much force, they are asking, conductor X exert on a short conductor Y of length L, which is carrying a current I and is kept at point P parallel to the conductor X. Now in second part, they are asking, another long wire Z carrying a current I2 is now kept parallel to X and Y at a distance R2 from Y such that the conductor Y remains at rest. You have to obtain the relation between the currents I1 and I2. So students, this problem is very simple but little bit tricky. So we will proceed for the solution. So students, first, this conductor Y, it will experience magnetic field due to current in the conductor X. Now students, this conductor Y is at a distance R1 from conductor X. So here students, we will first write the magnetic field experienced by conductor Y. So here B1, it will be mu naught upon 2 pi into I1 upon R1. ये डेरिवेशन है जिसे हम डिराइव करते हैं मैग्नेटिक फील्ड एट द डिस्टेंस R from a wire, and this is a very simple derivation, so I am just using it. Now students, conductor Y is carrying the current I and is situated perpendicular in the magnetic field B1. अब स्टूडेंट जो मैग्नेटिक फील्ड होगा B1 कंडक्टर Y में, वो क्या होगा? इट विल बी इनवर्ट. नाउ स्टूडेंट्स, देयर इज रूल फॉर फाइंडिंग द डायरेक्शन ऑफ मैग्नेटिक फील्ड. आपको थंब जो है कंडक्टर एक्स में करंट के डायरेक्शन में करना है, तो जो फिंगल्स कर्ल होंगे वो डायरेक्शन देंगे मैग्नेटिक फील्ड की. और यहाँ पे फिंगल कर्ल किधर हो रहे हैं? इनसाइड हो रहे हैं. तो जो कंडक्टर वाई जो है मैग्नेटिक फील्ड को एक्सपीरियंस करेगा ड्यू टू करंट इन द कंडक्टर एक्स, वो क्या होगा? इन्वर्ट हो. नाउ स्टूडेंट्स, ये कंडक्टर वाई है, करंट कैरी कर रहा है, एंड जो मैग्नेटिक फील्ड है दैट इज परपेंडिकुलर. तो स्टूडेंट्स, magnitude, now we have to calculate the magnitude of force acting on the conductor Y of length L. तो स्टूडेंट्स कंडक्टर वाई पे मैग्नेटिक फोर्स लगेगा ड्यू टू द मैग्नेटिक फील्ड क्रिएटेड बाय कंडक्टर एक्स. So here students, we will write that magnetic force, and this magnetic force is equal to F is equal to I. I is the current flowing in the conductor Y. B1 is the magnetic field due to current in the conductor X, and small l is the length of conductor Y. और मैग्नेटिक फील्ड और करंट इन दोनों की डायरेक्शन क्या है यहाँ पे सॉरी मैग्नेटिक फील्ड और करंट they both are perpendicular, so angle will be 90 degree. So here it will be sine 90 degree. So here F will become mu naught upon 2 pi I I1 upon R1 into L. So this is the magnetic force acting on the conductor Y. Now students, ये तो फोर्स था. This was the force conductor X exerts on a short conductor Y of length L, which is carrying a current I and is kept at a point P parallel to the conductor X. तो ये फर्स्ट पार्ट का सॉल्यूशन था. ये मैग्नेटिक फोर्स हमें क्या करना था, कैलकुलेट करना था. नाउ स्टूडेंट्स सेकंड पार्ट में क्या है, सेकंड पार्ट में पूछ रहा है अनदर लॉन्ग वायर जेट कैरिंग करंट I2 is now kept parallel to X and Y at a distance R2 from Y such that a conductor Y remains at rest. कंडक्टर Y कहां पे है, रेस्ट पे है. और हमें स्टूडेंट्स रिलेशन जो है ऑब्टेन करना है बिटवीन द करेंट्स I1 एंड I2. नाउ स्टूडेंट्स ये जो शॉर्ट कंडक्टर Y है, it will remain at rest if the magnetic force acting on it due to wires X and Y, they must be equal in magnitude but opposite in direction. तो स्टूडेंट्स पहले हम डायरेक्शन ऑफ मैग्नेटिक फोर्स देखेंगे. अब देखो यहां पे कंडक्टर एक्स पे सॉरी कंडक्टर वाई पे मैग्नेटिक फील्ड क्या है, इनवर्ट है ड्यू टू करंट इन द कंडक्टर एक्स. सो स्टूडेंट्स यहां पे क्या होगा, कंडक्टर वाई जो है कंडक्टर एक्स की तरफ अट्रैक्ट होगा. इज दिस क्लियर? कंडक्टर वाई पे जो फोर्स लगेगा उसकी डायरेक्शन क्या होगी, दिस विल बी. इसके लिए भी एक रूल है. एंड स्टूडेंट्स अगर हम कंडक्टर वाई पे मैग्नेटिक फील्ड देखें ड्यू टू करंट इन द कंडक्टर जेट, तो ये क्या होगा, उसकी डायरेक्शन इट विल बी आउट ऑफ द पेपर, दैट इज आउटवर्ड. एंड स्टूडेंट्स कंडक्टर वाई पे मैग्नेटिक फोर्स लगेगा ड्यू टू द मैग्नेटिक फील्ड क्रिएटेड बाय मैग्नेटिक क्रिएटेड बाय कंडक्टर जेट, और उसकी डायरेक्शन क्या होगी मैग्नेटिक फोर्स की. नाउ स्टूडेंट्स यहां पे एफ वाई और ये एफ एक्स. अब यहाँ पे फोर्स देखो क्या होगी, फोर्स की डायरेक्शन जो है अपोजिट आ गई है, और फोर्स जो है इक्वल इन मैग्नीट्यूड भी होना चाहिए. तो स्टूडेंट्स फोर्स अगर इक्वल इन मैग्नीट्यूड होगा एंड अपोजिट इन डायरेक्शन होगा तो क्या होगा, कंडक्टर वाई विल रिमेन एट रेस्ट. So now students we will obtain the relation between current I1 and I2. So now force due to wire X ये कितना होगा, first we will write the formula for magnetic force. ये क्या होता है, I B1L, बिकॉज यहाँ पे एंगल क्या है, थीटा, इट इज इक्वल टू 90 डिग्री बिकॉज मैग्नेटिक फील्ड इनवर्ड है और करंट दे बोथ आर परपेंडिकुलर. नाउ स्टूडेंट्स नेक्स्ट फोर्स ड्यू टू वायर एक्स वी विल कैलकुलेट. तो ये कितना हो जाएगा, एफ एक्स इक्वल टू म्यू नॉट अपॉन 2 पाई आई I1 upon R1 into L. Now student next we will calculate force due to conductor jet. ये कितना हो जाएगा, F jet. If you will calculate it will come out to be mu naught upon 2 pi I I2 upon R2 into L. नाउ स्टूडेंट्स, फॉर इक्विलिब्रियम के लिए कंडीशन क्या होगा? एफ एक्स शुड बी इक्वल टू एफ जेड. तो हियर स्टूडेंट्स, हियर म्यू नॉट अपॉन 2 पाई I1 upon R1 into L, it should be equal to mu naught upon 2 pi I2 upon R2 into L. Now students, जो सेम क्वांटिटीज है वो कैंसिल आउट हो जाएंगी, तो क्या होगा? म्यू नॉट अपॉन 2 पाई, म्यू नॉट अपॉन 2 पाई विल गेट कैंसिल, आई एल एंड आई एल will get cancelled. So his students, here we are left with I1 upon R1, it is equal to I2 upon R2. And students, here I1 R2, it will be equal to I2 R. So this is the relation between current I1 and, so this was the solution of this problem. Now students, we will proceed for next problem. Question number 13. They are asking, a monochromatic ray of light incident on one refracting surface of an equilateral prism suffers a deviation as shown in the figure 7 given below. You can just see. You have to calculate the refractive index of the material of the prism. So students, refractive index के लिए formula क्या होता है? In terms of angle of prism and deviation, sin A plus delta by 2 upon sin A by 2. नाउ स्टूडेंट्स, दिस इज एन इक्विलेटरल प्रिज्म, तो इसके लिए एंगल ऑफ प्रिज्म की कितना हो जाएगा? 60 डिग्री होगा, और डेविएशन जो कितना है? 40 डिग्री है. तो स्टूडेंट्स, विल कीप द वैल्यूज, so it will become sin 50 degree upon sin 30 degree. And students, if you will calculate this, it will come out to be 1.53. ये refractive index आएगा. So if you will calculate this, it will come out to be 1.53. So this was the solution of this problem. And in second part, what is meant by dispersive power of a transparent material? So ये simple definition है. And in next part, students, you have to draw a level diagram of an astronomical telescope when its final image lies at infinity. So simple, yes, students, आपको diagram draw करना है. So it is also given in the book, and I have taught this also in the class. So next, we'll proceed for next problem. 15. Now, students, in question 15, Kabir and Neha conducted experiments on light as a part of their school project. Both of them worked with the same source of monochromatic yellow light. Both obtained patterns on the screen, which consisted of alternate bright and dark bands. The images below depict their results. As you can say, this is the result of Kabir and this is the result of Neha. And in first part, they are asking identify the phenomenon observed by Neha. तो स्टूडेंट, नेहा कौन सा फिनोमिना ऑब्जर्व कर रही है? तो स्टूडेंट्स, अगर आप नेहा के रिजल्ट को केयरफुली ऑब्जर्व करोगे, तो हियर यू विल फाइंड दैट नेहा's pattern consists of central bright band, as you can see, this is central bright band, and it is wider, and side bands are narrower. And students, it is a characteristic of diffraction of light. So students, it is the characteristic of diffraction. Now, in second part, they are asking, the teacher asked Kabir to replace monochromatic yellow light with white light. What would be Kabir's observation now? So students, अभी तो जो कबीर का जो रिजल्ट है वो क्या है? वो कौन सा फिनोमिना शो कर रहा है? नाउ स्टूडेंट्स, ये जो है इंटरफ्रेंस है। ओके, बट स्टूडेंट्स अगर हम येलो लाइट को रिप्लेस कर दे व्हाइट लाइट के साथ, सो स्टूडेंट क्या होगा फिर? व्हाइट लाइट में स्टूडेंट्स मैनी वेवलेंथ होते हैं, और ऑब्जर्वेशन क्या होगा? जो सेंट्रल फ्रिंज होगी, सेंट्रल जो फ्रिंज होगी, सेंट्रल फ्रिंज स्टूडेंट्स, इट विल बी वाइट, इट विल बी प्योर वाइट। एंड स्टूडेंट्स जो साइड फ्रिंजेस होंगे, दे विल बी colored, and students fringes become less distinct. So fringes will become less distinct. Now students, now we will see next part. Now students, in next part they are asking what conclusion would be drawn by Kabir and Neha about the nature of light. So students, ये जो both experiments हैं, interference diffraction, they are wave phenomena. तो conclusion क्या होगा? Light has wave nature. So this was the solution of this problem. Now in next, again derivation, question 16, using Huygens wave theory and a label diagram so that the angle of refraction R is equal to angle of incidence. So ये simple derivation था. It is given in the book and I have taught this in the class also. Now next, question number 17. In 17, they are asking, the graph below shows variation of stopping potential versus frequency of incident radiation for metals A and B. So students, we'll proceed for the solution of this problem. Here, in the problem, they are asking to that UV radiation of appropriate wavelength is allowed to fall on both the metals. Which metal will emit photoelectrons with higher maximum kinetic energy? And you have to give a reason for your uh, statement. Now, students, from the graph, if you will analyze the the threshold frequency, that is FOB for metal B, it is greater than threshold frequency for metal A. That is FOB is greater than FOA. And students, as we know, for photoelectric effect, what is the formula for maximum kinetic energy? Kinetic energy max, it is equal to H mu minus mu 0. And students, there is same UV radiation, so same mu will fall on both metals. And students, for metal A, if we will write maximum kinetic energy, it will be H mu minus FOA. And students, this is for metal A, and for metal B, the maximum kinetic energy uh, is given by H mu minus FOB. And students, here, as you can see, FOB is greater than FOA. So here, FOB, it is greater than FOA, So students, here the maximum kinetic energy for metal A, that is K max A, it will be greater than maximum kinetic energy for metal B, for metal B. So students, metal A will emit photoelectrons with higher frequency. So metal A will emit photoelectrons with higher frequency. So this is the solution of this problem. So students, in the next problem, you have to state the conclusion that was drawn from Davison-Germer's experiment. And students, so students, as we all know, the conclusion of Davison-Germer experiment, what is that? That electrons are wave-like. Electrons are wave-like in some circumstances. In some circumstances. So this is the conclusion that was drawn from Davison-Germer's experiment. So this was the solution of today's all problems. And if you have liked my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.